What is going on, guys? Welcome to another video in my tutorial series where we talk about multiplexers. Now, what a multiplexer is basically a device in your computers or machines that takes 2 to the n inputs and spits out 1 output. Alright, and to do that, we're going to need something called a selector. And a selector is basically a line or a wire that is going to essentially pick one of the 2 inputs right here and set it to be our output. Alright, so let's take a look here. Can you guys identify a relationship between this? Alright, I'm just gonna go ahead and put it out there. The relationship between these two, for as far as a multiplexer goes, is 2 to the n inputs is going to give us an n number of selectors. All right. Now, why don't we go ahead and draw a little truth table for our. Oh, also, let's see. This is going to be called a 2-1 multiplexer. All right. So why don't we? If I label this I0, I'm going to label this I1. and as I've said before, because we have 2 inputs, we're going to have 1 selector. So I'm just going to label this S. And I'm going to label our output Y. Alright, so if I go ahead and draw the truth table, really, the only thing that's going to determine the output is this selector right here. So if we had S as our input, our data selector input, and we take a look at our output, all right, what are the possible values for S? Well, it can either be 0 or 1, right? These are the 2 states of our selectors. Now, when this is 0, when this is set to 0, we want the very first value to be our output. So when this is set to 0, we want I0, and when this is set to 1, we want I1. Alright, that was pretty simple. Now, why don't we go ahead and draw little functions for these things right here. Alright, so we can have Y, our output, equals to S, not S. Right? Not S in this case because this is set to 0. Not S and I0. Now let's take a look at our other one right here. Y also equals to S and I1. Okay, so these are our 2 possible outputs. And because we can only select one of these 2, we'll run them through an OR gate. So Y equals to not S I0 plus S I1. Okay, I hope you guys understood this part because you're going to be using this form of deduction very, very often, especially if you forgot how the actual gates look like for these. So when we take a look at this, what's the first thing that comes to your mind? Well, the first thing that should come to your mind is you notice these are basically comprised of AND gates. And why is that? Well, because remember, the multiplication or the inferred multiplication here represents an AND gate in digital logic, and this plus sign represents our OR gates. All right, so let me go ahead and draw that out for you guys. So we know for a fact we are going to have 2 inputs because we have I0 and I1. That's our possible outputs, and we're going to select one of those. So why don't we put this I0, I1. That's our 2 possible inputs. Now we're going to have 1 selector. I'm just going to put our selector, no, I'll just put it right here. I'll put our selector right here. And our selector will be either on or off. Right? So I'm going to run it through. Oops. I'm going to run it through my OR gate. My NOT gate right here. Okay. Now, the next thing I like to do is let's take a look at the very first equation we have here. All right, we have not S and I0. Now, what does that mean? that just means not S, and the input of I0 is going to be connected to an AND gate. Because remember, this stands for an AND gate. So why don't we do that? I'm going to draw my little AND gate here. And let's see, let's connect not S, which is this, which runs through this NOT gate here. And I'm going to connect I0 right there. And now let's take a look at the next one. We have S and I1 connected to the second AND gate right here. So S right here and I1. Okay? Connected to that right there. Now that we have these two hooked up, we're going to need an OR gate because of this plus sign. So we're just going to simply do that with this. And that is how the circuit diagram looks like for a multiplexer, or at least a 2-to-1 multiplexer. Okay? Now I hope you guys enjoyed this video, and I hope with what I've shown you guys here as far as the truth table goes, you guys are going to be able to construct even more complex multiplexers, be it a 4-to-1 multiplexer or a 8-to-1 multiplexer. Alright? If you guys like this video, please go ahead and hit that like button down below, and don't forget to comment and subscribe, and I'll see you guys in the next video. Bye bye.